Hi folks, this is Nikhil and you are learning GoLang with me. In this particular session, I'm going to talk about the most important aspect of any programming language, that is to deal with the errors. In the programming language or in the real world, it is naive to think that you will never ever encounter with the issues or the problems or the errors. In the real world, many times you get the issues in number formatting, in the parsing. Most of the times the things go for a toss, and you have to handle the errors, you have to face the errors first, and then you have to understand that there was an error, and then depending upon the severity you have to handle the error. And that's why in most of the languages you find the very very procedural error handling process. For example, in Java, if you have worked with the JVM or the Java based languages, then I'm sure that you must be aware of the try catch error handling, or let's say error delegation in Java. So you have the try catch finally block, and then now you with Java 8 you have the with resources. So error handling has to be pretty much there inherent into the language. And in GoLang also you do have very powerful error handling process. So let's see what is that. So in GoLang we don't have the concept of catching the error. So in fact the language is built in such a way that whenever you deal with the resources, for example, let's say you are dealing with the IO, in case you open the file or you close the file or you read the file, automatically there is the inbuilt handling of the error. And then in order to have the customized error handling, you need to or you can, you're not required to do so, you can so you can actually get the output of the error into one variable. You can check whether the variable let's say that error variable is not nil, and if it is not nil, then you can handle that particular error in the customized fashion. So in any sense, the GoLang's capability to deal with the errors is much more mature and powerful as compared to the other languages. Now in this session I'm going to demonstrate two things. One thing is the inbuilt error handling capability of GoLang, and then second thing is, whenever you want to throw the error, or let's say whenever you have the potential use case of having the error in the program, then how to deal with that. So let's get started. So first thing that I want to demonstrate to you is let's say how this error handling is inherent in the GoLang. So let's say even though we have not dealt with the file, so let's say you want to open the file. Let's say it is very simple in GoLang. You have to provide os.open, or it's open file. So now there are two modes. I will explain the difference in between these two APIs in the specific session dedicated to the files. But let's say you want to open this employee.json file, right? So now I will say that os.open employee.json, and let's see what does this API return. Now this API takes in the name, the file name, as the let's say the input parameter, and then it returns two results. One is the file handler, which is the pointer, and other value that is going to get returned is the error variable. That is absolutely important to understand what is that. So if I just go into deeper and if I see the invocations call stack, then you can see that you have this error and then the file. then open, oh, this is just the logger, so I will, and then this is the open file, no log. Now over here you can see that again it is giving the error, which is the variable. Now let's say if there was any issue in the opening the file, then what will happen is you have this var e, which is of type error, and then the re, so syscall.open, if there is any error in the if there is any error in the opening the file, or let's say in this API maybe that file does not exist, or maybe that file is not fitting into the memory, whatever is there. So you will see that all of the method invocations are returning this error variable, and then finally this will go into the low level instructions, and we are not really required to go into the details of that. So the point is you get two variables in return. So let's say this is my file, handler, which is the first one, and the other one is the error. As you know, in GoLang I don't have to actually declare the error, which is the type of error, or let's say the file pointer, which is the type of the file handler. Automatically the compiler will understand and will infer the types associated with these two return values. Now what I will do next is if error is not nil, then I will say that file handler dot let's say close. I just want to close it. Otherwise, else what I will do is, so let's say if error is equal to nil, then I will just close the file handler. Otherwise, what I will do is I will just let's say display the error. I will not handle it as of now, because that's what I don't want to do over here. So I will just display the error, and then there is no need to close the file, because anyway the file handler is not there. This variable was not populated in case of the error. Now let's say I just want to run this program. So now you can see that there is no such file employee.json, because the file name is employees.json, right? So you now understand, you can now understand what is happening behind the scene. Right now, in, let's say if I have similar program written in Java or Python, or let's say Scala, I would have just witnessed, or I would have encountered with the stack trace, the entire stack trace, like let's say file open, then open calls another open file calls sys dot open file. So I would have noticed that entire call stack, and then I would have let's say I would have encountered with file not found exception in Java, and then the entire program would have just stopped. That's it. But in case of the GoLang, because as I said earlier, the error handling is much more mature, so that's why whenever you deal with the resources, or whenever there is a potential error handling scenarios involved, automatically the GoLang has the inherent support. So that's why you don't have to worry about the error, or you don't have to worry about the error handling. What you just need to do over here is just understand whether the error is not nil, and then only go ahead with the file handler process. Let's say you want to read the file, and then you will say, okay, get me the contents of the file, and then you process the file content. Now in case of the error, what you will do generally, you will see that okay, now error is there, anyway you can't do anything with that. If the error is, let's say, no such file or directory exists, then you may try to change the names or here and there, or you can have the directory scan, and then you can say, okay, now load the file, something like that. Otherwise, you just display the regular behavior, whatever you want to perform as a part of the program, and then you just exit. That's it. So that's the first part. So the first part is inherent error handling in GoLang, right? This is the inherent error handling. So you have the error variable of type error, and so this includes the, let's say, the population of error or variable of type error, and then handling or let's say checking whether error variable is nil, is not nil, right? So that's what we have just done. Now second part is about the let's say throwing the error, or let's say not having this inbuilt capability, because this is customized program. So what would happen in case you don't handle the error? Let's see that situation. So now let's say we have one function which is named as display. What display does, the display just displays the value of the counter that is passed to the function. Now the function displays the counter value until the value is not 4, okay, or let's say let me modify, it is not greater than or equal to 4, not 4, and is not greater than or equal to 4. If it is less than 4, then what counter would do is, first counter has the defer function invocation. So basically, as you know, or you must have seen my defer function video. So in defer, what happens is, whenever there is a call to the defer, then the input parameters are evaluated, but at the same time the function is not executed. The function evaluation happens afterwards. So function execution happens afterwards. The function is pushed onto the call stack, and then whenever you complete the function call, then only that particular function gets executed, right? So let's say in case of display, what would happen is you pass, let's say now you want to invoke the display function. So let's say you start with 0 over here, right? So you start with 0, then the 0 will be passed to this method or this function. However, the execution will be on the call stack. The variable counter will be stored against the call stack execution of this deferred function. Then counter is not 4 and it is not greater than 4, so that's why this block, this if block, will not get executed, and it and finally the instruction pointer will come to the display, and then the counter will be incremented by 1. Then counter value will be 1. Then in that call stack also, now this is the second call stack for the display. Remember that it is the recursive function. So again, in that case also the display function, this particular function, the sub function inside the display will be deferred. However, at this point of time, now the counter value that is evaluated, the value will be 1, right? Now again the counter is not 4, so the display will be called with the counter plus 1, which is 2. Then the same thing happen again. Now counter will be called with 3, and then counter will be called with 4. Now when the counter is called with 4, again the deferred function, the counter variable that is going to get passed as the input parameter to the deferred function, the value is 4. This display will not happen because the execution is deferred. And now over here, if counter is greater than or equal to 4, now over here the counter is 4, so 4 is not 4 is equal to 4. So what will happen is, the instruction pointer will come to the panic, and it will call panic with the let's say this is the way in which you pass the parameter to the panic. What is panic? Panic is the way in which the function, or let's say the GoLang program, can handle the error or can throw the error. So error handling is throwing the error and then handling, catching the error, right? So if I want to compare this with the Java world, then I will compare this phenomena in the following manner. So the error handling in any language has to deal with three parts. One part is you have the capability to throw the error. So in Java you have the throw keyword. In GoLang you have the panic, let's say panic keyword. Then second part of the error handling process is to catch the error or understand that yes, there was an error. So that in Java is done by the catch, and in GoLang it is done by the recover, which we will see in the next video. And the third part is to actually do something, or let's say in case you decide to catch the error or you don't catch the error but you want to execute something in any case, like let's say you want to close the file handler, you want to close the resource, any of the resource. Let's say you have the XML file and then you have the pointer to that file, so you want to close that pointer, right? So you want to close that file or that handler. That you do in Java as a part of the finally block. In GoLang it is done with the help of the defer or defer, right? So now in this demonstration, now the second part of the demonstration, we are going to use panic. The panic is the built-in function which stops the normal execution of the current Go routine. When a function f calls panic, normal execution of f stops immediately. And in any functions whose execution was deferred by f are run in the usual way, and f returns to its caller. To the caller g, the invocation of f then behaves like a call to panic, terminating g's execution and running any deferred functions. G is the caller of function f. So g over here in our case is the main program, right? The main function, and f in our case is the display, right? Let's move on. Then to the caller g, the invocation of f then behaves like a caller to panic, terminating g's execution and running any deferred functions. This continues until all functions in the executing Go routine have stopped in reverse order. At that point, the program is terminated and the error condition is reported, including the value of the argument to the panic. This termination sequence is called panicking and can be controlled by the built-in function recover, which we will see in the next session. So now, let's say in case of counter 4, the panic will be called. Then what would happen is the normal execution of the display will be stopped, right? So display counter plus 1, that is display 4 plus 1, display 5 will not be called. Display 5 will not be called ever, and then will never be called. And then as we have just seen the documentation, now you have the deferred function that get that all of the deferred functions that get into action. So now on our call stack we call the display, let's say 0, then so display 1, display 0, display 1, display 2, display 3 and display 4. So in our call stack we have 5 deferred functions. All of those deferred functions will get executed, and then finally if there is any defer function over here, that will also get executed. So in this particular demonstration I am not going to handle this error. I just want to demonstrate how the call stack gets unwinded in case of the panicking, and then how finally if there is no any deferred function and then there is no let's say the recovery of the panic, then how the GoLang reports the issue. That's what we are going to demonstrate. So let me just call this function right now. So now you can see that you have the first error handler, which is normal one, the first way of handling the error, which is the inbuilt error in GoLang. Now you have deferred, starting with the last defer, executing deferred function in display 4, So this one, executing default function in display 4, in display 3, display 2. So as I said, 5 default functions in the call stack, and then whatever value you have just passed as a part of the panic. So let's over here I have passed counter, so the panic is with value 4, and as I have not handled the panic, so that's why you do see the reporting of the error code. So you can see that you have the panic over here, then how the entire call stack was unwinded, right? That's what you have in the reporting of the error. So that's it for now. You have just learned how to deal with the errors in GoLang, and then what is panic, and then how that panic, or let's say panicking, works in GoLang. That's it for now. See you in the next session.